So Unit 8 is going to be all about right triangles. And the best tool we have available to us for solving right triangles is the Pythagorean Theorem. Now I know you've all seen the Pythagorean Theorem before. That's the c squared equals a squared plus b squared. So we're going to take that a little bit farther and use it to solve some missing parts of a triangle. And before we can do that, though, we kind of have to review some topics that I know you've seen before, but some students just kind of struggle with it. So we're going to go over it again. It's how to simplify a radical, okay? And by simplify, I mean get all the numbers out of underneath the radical possible. So just to remind you how a number gets out from underneath the radical, okay? So for instance, if I had the square root of 12, okay, I could break 12 into two separate numbers. I could say this is the square root of 4 times the square root of 3, right? Because 4 times 3 is 12. And we know that the square root of 4, okay, 4 is really 2 times 2. There's two of these to make a 4, right? 3 is just 1 in itself, so there's nothing that goes into 3. 3 is a prime number. But there's two 2's. It's 2 to the second power, right? 2 times 2 is 2 to the second power. So this is why when you take the square root of 4, it becomes a 2, right? Because this is the same thing as saying 2 to the second power. And a square root and a second power cancel each other out. So all I'm left with is the 2, because there's two 2's. It's 2 to the second power. Well, the second power and the radicals cancel. So I would simplify and I would get this. Okay? So we're going to do this to simplify 120 in a very similar manner. We're going to do something called prime factorization. Okay? Okay, prime factorization is where we try to get prime numbers so that the other numbers can move outside the radical. Okay, so the way we do that, remember prime numbers are things like 2, 3, 5, 7, 11, 13, things that can only be divided by 1 and itself. So we're going to start to prime factor 120. I'm going to make a little tree, okay? And for every branch, I'm going to put a prime number on this side, and 2 times 60 equals 120. Okay, those are factors of 120. This is a prime factor. This is not. It's what we call a composite number. So we're going to break this one down again. Again, on the left, I'm going to write a prime number. And 2 times 30 equals 60. 2 is a prime factor, 30 is not. So let's break 30 down. Good. 2 is a prime, 15 is composite because it is created out of 3 and 5. These two are both prime. Once you get to the end of your trees and there's nothing but prime numbers left, okay? So if I were to take a highlighter here, and at the end of my tree, these are primes, these are all primes, and there's no composite numbers left, right? So what I'm going to do is, after I get my pen sorted out here, okay? So remember, we're looking for things to the second power. So 2 times 2 means 2 to the second power. So here's a 2 times 2. So that's 2 to the second power. It's 2 by itself, 3 by itself, 5 by itself. Okay? So remember, 120 is under a radical. So if I took 2 to the second power times the 2 that was alone, times the 3, times the 5, and I multiply these all together, I would get 120. These are the prime factors of 120. Now, anything to the second power, we talked about how we can look at that, and what's going to happen is the square is going to cancel and that number is going to move outside. So I'm going to have a 2 on the outside. Then I'm going to have my radical, and I have a 2 that was by itself, a 3 by itself, and a 5 by itself. So to finish this all up, I'm just going to multiply these back together because they don't have a square, they don't have a partner that lets them come out. So that 2 that came out is still out there. 2 times 3 is 6. 6 times 5 is 30. So this right here is the what 120 would reduce to. All right? We break it into prime factors, and then we look for any doubles so that a number can come out. So let's look at another example. 96. Okay, so we're going to prime factor 96. Okay, so let's see. We can do a 2. That's 48. And that's a 2, which is 24. That's a 2, and that's 12. It's 2 and 6. 2 and 3, and I have no more numbers to break down. Okay? I've reached the end of my factor tree. Those are my factors. So remember, every combination of 2, right, there's 2 of those, so they're going to be something that comes out of the radical, right? That has something that comes out of the radical. Remember, because 2 squared will come out and be a plain 2 on the outside. 2 squared will be a plain 2 on the outside. He doesn't have a partner and he doesn't have a partner. So they'll go back under the radical. So I'm going to have a 2 that came out, another 2 that came out, and under the radical I have a 2 and a 3. So 2 times 2 is 4. 2 times 3 is 6. So this is the reduced answer for 96. If you put square root of 96 into a calculator and it's able to reduce it for you, it will give you this answer. Okay? Let's do one more. 320. So let's start our factor tree. 2 and 160. 2 and 80, 2 and 40, 2 and 20, 2 and 10, 2 and 5. Okay, no more numbers to break down. So we're going to go look for pairs, remember? Because we want to make groups of squared. So 2 squared will be a 2 on the outside. 2 squared will be a 2 on the outside. 2 squared will be a 2 on the outside. 5 does not have a partner, so he will remain under the radical. So I have a 2 on the outside, a second one, a third one, and 5 that had to stay under the radical. 2 times 2 is 4. 4 times 2 is 8. So, oops, I said 8 and I wrote it. Sorry, do you guys ever do that? Okay, or like you say a word and then you accidentally write it and you don't mean to. Okay, times 2, radical 5. 8 radical 5. Okay, so this reduces to 8 radical 5. Okay? All right, so I think you're getting the hang of that. So let's skip straight over to some Pythagorean theorem, okay? Here's where you're going to really want to write stuff down, okay? So Pythagorean theorem, there's a lot going on here, all right? First of all, what's going to be really important every time we do the Pythagorean theorem, every single time, okay? You need to find the hypotenuse, which is side C. You need to find this first. Okay, that's always the first thing you do, is find the hypotenuse. Okay? And the hypotenuse is going to be the side that is away from the 90-degree angle. So here's my 90-degree angle. My hypotenuse is going to be the one that's away from it. So this right here, ladies and gentlemen, that is my hypotenuse. I'm going to find that first, and I mark it down. There it is, there it is. There's the hypotenuse, I put it on the paper. First thing that happens, okay? That's my C. Hypotenuse is always C, so I mark it, okay? The other two pieces become my A and my B, okay? Those are called legs. Leg A and leg B. Leg A and leg B. It doesn't really matter what combination you use because they're just going to get put into the formula. Okay? So it's super important you find C first. Then go find your A and B. Okay? And it's always the one that's away from the 90. See how A and B touch 90? So those can never be C because they touch the 90. Okay? So there's something I want you to write down here, okay? I'm going to try to make your life a little bit easier. So we all know that the Pythagorean theorem, looks something like this. C squared equals A squared plus B squared. Okay? Now, sometimes these squares get to be a pain in the butt. Like if you need to know what C is and then you got a square root and it just becomes kind of a hassle. So, to do you a favor, I'm going to rewrite this, okay? C is equal to the square root of A squared plus B squared. Okay? What I did is I took the square that used to be here and I made a square root on the other side, right? So they undid each other. So I took the square root of both sides, hence it disappeared. So this is the one, if you need to solve for your hypotenuse, just plug your A and B into this, okay? I want you to do less work if possible, all right? You might be wondering though, okay, but what if we're missing A or B? Great question. We can rewrite this to look like this. Okay? Or you might say, okay, so if we're missing side A, do this. Okay, you're going to want to write these down. So depending on what you're missing, just use the formula that goes along with it. You could do the same thing with B squared. Just going to kind of do this here, hang on. Okay. If you're missing side B, I want you to do this one. So there's your three equations that you're going to use for the Pythagorean theorem. Okay? So you're going to have this one, or this one, depending on which side you're missing in the problem. Okay? So make sure you have those written down. Pause this video if you have to, and then let's do some practice problems. Find the missing length. Okay, so before I do anything, I'm going to find the hypotenuse. Here's my 90. So this is my hypotenuse. Okay, that's my hypotenuse. So I know that I'm missing side C. All right, so since I'm missing side C, I know that the other ones are A and B. So I'm going to put this into the equation that tells me what C is, okay? And that equation that told me what C was C equals the square root of A squared plus B squared. Okay, so I'm just going to put numbers in here. All right? So I know that C is going to equal the square root of 8 squared plus 13 squared. Okay? And when I put that in a calculator, right, when I put that into a calculator, I'm going to get C is equal to the square root of, back to green, 233. And I'm going to leave my answer just like this, because it's going to want your answer in simplified radical form. Okay? And you can put this into a calculator to see if it reduces. It doesn't, so we're going to leave it. We're going to leave it. Okay? I don't want a decimal. I want this. This is my answer. So that's all we're doing. We find C, A, B, figure out what I'm missing, and then use the proper formula. Let's try another example. Find the missing length. Well, first I'm going to find, here's 90. So this is my C. This is my hypotenuse. All right. So I can record that C is equal to 9, which means the other ones are, let's call this A and B. So I'm solving for B in this case. So I want to know what B is, and B is going to be equal to the square root of C squared minus A squared. So B is equal to the square root of 9 to the second power minus 7 to the second power. Okay? That equals the square root of 32. And I can prime factor that, and it ends up being 4 radical 2. There you go. That is how you use the Pythagorean theorem to find a missing side. Let's do one that's slightly more complicated. Ooh, that's got a radical in it. So, hypotenuse. Okay, so I'm going to record that. C is equal to 15, which means we can call this A and this B. Again, it doesn't really matter which is which. So A is equal to the square root of 3. B is equal to X. So we're going to use B is equal to the square root of, remember, C squared minus A squared. Okay, so C squared is 15 squared minus, my A is the square root of 3 to the second power. Okay, so this, if I want to look at this specifically, I could type this right into a calculator, keep the parentheses there, they're important, right? But if I'm going to examine this just a little bit further, okay? Well, 15 times 15 is 225. Now, I'm going to square a square root. Now, we just had the conversation, right? We just had the conversation that a square and a square root cancel each other out, so I'm left with just the 3. So I have minus 3, right? Square and square root cancel each other, so I'm left with just the stuff that was underneath. So I write just 3 down. So my answer, when I'm all said and done, right? Sorry, it's a little chunky there. Is 222. Okay, that's it. 222. So that's how we use the Pythagorean theorem to try to find missing sides. Okay? So we'll have to practice some of those. And then we'll come back for another video on how to do something called the Pythagorean converse.